Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to demonstrate how to find the sum of arithmetic sequences. We're going to go through the 4 examples I have listed here, and I'll talk about these later. We'll just talk about this one for now. So we're going to look at the sequence 3, 6, 9, for 20 terms, and we're going to try to find the sum of that sequence. So here's a couple things we're going to need. One, we're going to need a formula for the a sub n. And hopefully you've seen my videos here, or anybody else's videos, on how to find formulas like that. But this is going to look something like some sort of a1 plus a difference times n minus 1. And this is true starting if you start at n equals 1. And we're also going to need a formula for calculating the sums. And the sum of an arithmetic sequence is equal to n over 2 times a1 plus a sub n. All right. So we're going to need both of these, and let's start with this one here. So this series is described by these numbers. The a sub n is going to equal 3 plus, now to get from here to here we're adding 3, here to here we're adding 3, and so forth. So the d is 3 times n minus 1. We're going to need the 20th term, so a20 is going to equal 3 plus 3 times 19 by the time we do n minus 1. And I think what I'll do here is just calculate the value. I get 60 out of that. Alright, so the sum of all of these terms should equal n over 20. That's going to be, I'm sorry, n over 2. That's going to be 20 over 2 times a1 plus a sub n. That's going to be a1 plus a sub n, and I get a value here of, well, let's see, I guess that's 63 times 10, 630 is what these add to. That wasn't so bad. All right, we're going to take a look at this example. I'll probably need a little more room. All right, going through the same process here. So first thing we're going to do is we're going to need a formula for the a sub n's. A sub n is going to equal our starting point, 20, plus, okay, the difference now from here to here, that's we have to subtract 5 from here to here. Again, we're subtracting 5 and so forth. So our difference is minus 5 times the quantity n minus 1. Now I'm going to go ahead and calculate a sub 40. That's going to be 20 minus 5 times 39 by the time we do n minus 1. Right, I get negative 175. All right, so the sum, just going to apply this formula now. Going out 40 terms, we're going to have 40 over 2 times the quantity, let's see, a1, I'm getting that from here, plus a to the n, minus 175. I'll just put that in parentheses. All right, so let's see what we get out of this. I get minus 3,100 out of that. All right, 2 down, 2 to go. Let's talk about this guy right here. I'm going to move this up, give myself a little more room. I think what I'll do is, so that you can keep these straight, I'll put some lines between these examples. There we go. All right. So first thing we're going to need is the a sub n. Now notice they get from here to here, that's plus 6. From here to here, plus 6. So this is an arithmetic sequence. Let's see, the a to the n is going to equal 4 plus the difference times n minus 1. And again, this is true starting at n equals 1. It would just be n here if we started it at n equals 0, but I want to be consistent with the book that I'm using for this class. We're going to need the 25th value. That's going to be 4 plus 6 times 24 by the time we do n minus 1. I get 148 out of that. All right, so the sum of that sequence, let's see, adding them all up, we are going to have n over 2 times the quantity a1 plus a to the n, or in this case a sub 25, I guess, running a value here. I get 1900 out of that. All right, last example. I'm going to need a little room. So why don't we maybe take this. There we go. And again, I'll put a green line here between examples. So I'll start with this guy. So arithmetic sequence again, to get from here to here, notice that we're adding 5. From here to here, adding 5, and so forth. So our a sub n is going to equal -4. That's our a1 term, plus our difference, times n minus 1. Again, this is true starting at, if you start at n equals 1 instead of n equals 0. All right, we're going to need the 16th term. So that's going to be -4 plus 5 times 16 minus 1. Oops, a little hard to read that. 16 minus 1 is 15. So that's what, 75 minus 4, 71. Just double check that. Yeah, I think it's good. All right, so the sum of that sequence is going to be n over 2 times the quantity a1 plus the a sub 16. And let's run a value and see what we get out of that. I get 536. So we're happy. All right, so the purpose of this video is to demonstrate how to find the sum for a generic n for given arithmetic sequences. You start by coming up with a formula here for the arithmetic sequence, calculating the value at n equals whatever number you're looking at. In this case it was 20, in this case it was 40, here it was 25, here it was 16. Then you calculate the sum by taking n over 2 times a1 plus a sub n. I went over this, where that comes from, in a previous video, so I don't feel like I need to do that here. I hope that this helps demonstrate these concepts. Have a great day.